I am Prabhakar. Today we will be discussing properties of vectors and their relevance in science and particularly in physics. Let us take for example, there are quantities in physics which are generally characterized as either scalars or vectors. When we say a scalar, we mean a quantity which is specified with a certain magnitude, like for example, temperature, mass. They are all quantities which are represented by a certain magnitude, like for example, 2 kg, temperature 320 K. These quantities are specified by their magnitude and a unit corresponding to it, whereas quantities like velocity, displacement, acceleration are quantities which are specified not only by a certain amount magnitude, but also a specific direction. Why do we need these quantities with a specific direction? Let us take some examples. Let us say O is a point and the location P is indicated in the figure. The direction of P is indicated by an arrow. Why do we do that? एक मिनट Quantities in physics are generally classified either as scalars or vectors. What are scalars? Quantities like say mass, which is specified by a number and a unit. Temperature is another quantity which is specified by a number 320 and a unit called Kelvin, represented here as K. There are quantities in physics which are called vectors, which are represented not only by a certain magnitude, say for example, displacement, velocity and acceleration. These are quantities which need the specification not only in terms of their magnitude, like for example, meter as a unit, 10 meters, but if you do not say in what direction, it does not mean anything. To illustrate, consider in the figure which I have drawn here, with reference to point O, point P is in a certain location. It is at a certain distance, say let us say 10 meters. If I say P is located at a distance of 10 meters, I am not very sure whether I have really specified the location of P. 10 meters could be here, but this is not the same point. Let us call it as P dash. If I say go from O 10 meters, you will reach P without specifying the direction. You may not reach that point at all. You may go in some other direction 10 meters and he has not reached that place. So, position of a particular object or a point in space is to be specified with reference to the origin, not only by the magnitude, but also the direction in which it is there. See for example, in this case P is located with respect to O at a distance of 10 meters, possibly you say at an angle of 45 degrees. This is one way of specifying. Another way of specifying could be that the location of P is 10 meters north of east. Is another way of, that is, as long as we are specifying not only magnitude in terms of 10 meters, but the direction either in terms of 45 degrees with respect to this axis and going in the anticlockwise sense. 45 degrees the other way will give a point which is very different, and I call it as P double dash. So, you should also specify the direction very clearly, and these are the quantities. This is a position vector. OP with an arrow is called the position vector of point P with respect to O. Consider a situation like this. Point O as a reference point, and I am confining myself to the plane of this board. Let us say the object is at point P at a certain time t. If the object is moving, the position vector as a function of time, that is OP is the vector at time t, which is the position vector. Now, if the point happens to be moving, it is going to be at a different place. Let us say it is at P dash at time t dash. The object has moved from point P, which was at time t, to another point P dash at time t dash. Now, OP dash is the new position vector. Position has changed from point P to point P dash in the interval t t dash, that is, it has taken a certain time for this object to move from point P to P dash. Now, there are two position vectors. If you join the line these two position vectors, we represent the third vector, which is called delta P. The change in position from point P to P dash, this delta P is called the displacement vector. The word displacement means the change in position of the point from P to P dash is represented in the diagram, that is arrow starting from point P ending at P dash. This is called the displacement vector. Change of position between 2 points, which has a starting point and an ending point, the change in position is indicated by what is called as a displacement vector. Now, look at this. It has moved from point P to P dash. I do not know how it has moved, in what path it has moved. Say for example, it might have moved like this. This could be the path. It could reach that point like this. This, let us take path number 1, path number 2. When we say displacement, we mean only the, we will consider only the beginning point and the ending point and join the line from the beginning to the ending and then mark an arrow there, and we call this as the displacement vector. That is nothing to do with this path. For example, if the distance displacement vector, let us say P P dash, is 10 meters in a certain direction. Now, if he or she has traveled in point path 1 and if they have traveled say 25 meters, 25 meters is called the length of the path, or generally what is called as distance. The distance between point P and P dash in this path 1 could be 25 meters, in path number 2 it could be 35 meters, but the displacement is only 10 meters and in a certain direction, and depends only on the initial and the final point and not the path. Now, when we are discussing about motion in one dimension, when the object moves in one dimension, that is along a straight path, there is not much of a difference because the path was very specified. The distance and the displacement could be same, could have been same, but displacement, when we say, that is the least distance and in a certain direction, whereas when you say distance, you do not specify the direction, you do not specify the path, it could be in any path and the distance can vary. For example, if you say Mysore, Bangalore, M and B I am just indicating here, the position of Mysore or position of Bangalore has to be specified very clearly, not by saying that the distance is 140 kilometers. That does not give any specification. If a person has to travel from Mysore to Bangalore, you need to specify clearly the direction. So, distance and displacement. Distance is the path length between 2 points and that varies from path to path, whereas displacement is the same. So, quantities like displacement and velocity and acceleration, they are vectors. Now, they need for the specification not only the magnitude, that is a number and a unit, but also the direction. Let us deal with those quantities and their behavior. How do you add, subtract, how do you multiply these quantities is what we are going to do. First, to begin with, how do we specify a vector? Specification of a vector is in terms of a magnitude. First, let us say, and this is a vector standing for could be velocity, could be displacement. I am not going to specify anything about the nature. I am just going to indicate this vector. The origin is O and the end point is A, and I call the representation of this vector O A. The length of this vector is its magnitude, and the direction is specified by this arrow from the beginning to end. O A is the vector. It has a beginning and an ending. So, it depends only at the beginning and the end point. Now, this representation is also done in another way. This vector can also be represented by simply writing A on top with an arrow. These are the two ways in which a vector is represented. O A very clearly saying, and this length, if you have chosen a certain scale and all that, you can specify. Now, if I represent a line parallel to it of the same magnitude, I have drawn a line parallel to vector O A indicating O B and with an arrow here. O B is a vector which is similar or identical to this, because it is parallel, the directions are same and the magnitude, the lengths are same. Then we say O A is equal to O B. These two are same, that is O A is equal to O B, because both of them, their lengths are same, their directions are same. So, when you say two vectors are same, we mean their magnitude and as well as the directions are same. Now, having understood what vector O A being equal to O B, meaning that their magnitude and the directions are same, are two vectors which are parallel and having the same magnitude are same. Now, if I draw a line parallel to this, let us say this way, having the same length, but the origin is the arrow beginning and ending are different. Say for example, this is x and this is y, even though the lengths are same, as you understand in the figure, x y vector x y is not the same as vector O A. The lengths are same, but the directions are opposite. So, when we say x y vector, if I call that as vector c instead of x y, that is beginning to ending, if I represent by a single letter with a arrow on top, vector A is equal to vector B, if I call this as vector B, and A is equal to vector B, but A and C are not same. We say A is minus of C, that is two vectors which are the same magnitude, but one being anti-parallel to the other, then we say vector C is negative of vector A, or you can also say vector A is negative of vector C. So, what we have discussed today is what do you mean by a vector and its equality. When are two vectors equal? When they are not equal. In the next unit, we will discuss the operations, that is addition, subtraction, and how vectors behave and their utility.